There will probably be technical glitches in this, so just bear with it. So the first thing we need to ask ourselves is, what is dimensional analysis? And dimensional analysis is just a systematic method, as it says here, that is used to convert from one unit to another by multiplying fractions. But the key is, what are these fractions? And the fractions that we used are called conversion factors, and a conversion factor is a ratio that is equivalent to 1. And let's go over some examples of what we mean when we say something is equivalent to 1. So, for example, you can have 7 days in a week, or you can write it 1 week and 7 days. And the reason that is considered equivalent to 1 is because they both represent the same amount of time. If we look at this next example, which you can already see the bottom of, we have 1,000 meters and a kilometer. So 1,000 meters and 1 kilometer represent the same distance. That's why they're considered equivalent to 1. And you can write that as a fraction or as a ratio. It's either as 1,000 meters over 1 kilometer or 1 kilometer over 1,000 meters. So just review: dimensional analysis, systematic method to convert from one unit to another, and we use fractions called conversion ratios. Excuse me, I just messed that up. We use fractions called conversion factors, and they are ratios that are equivalent to 1. So one of the things I've come up with, as I've taught this for many years, is a 5-step method to sort of help kids work through this, because sometimes it can feel daunting. And there we have our 5-step method for solving problems using dimensional analysis. And we're going to start with an example. We want to know how many grams are equivalent to 4.5 milligrams. So the first thing we're going to do is we are going to determine what unit we are starting with. And so that's what we know. And we know we are starting with milligrams. There's that 4.5 milligrams right there. The next question you can ask yourself is, what unit are we trying to get to? Or determine the final unit. And in this case, we want to know how many grams that's equal to. The next step, step 3, is we need to figure out what conversion factor or factors relate the starting unit with the final unit. Hopefully you're very familiar with your metric prefixes, and you know that there are 1,000 milligrams in 1 gram. So those are our first 3 steps. Determine the unit you're starting with, determine the final unit, and figure out which conversion factor or factors relate the starting unit with the final unit. On to step 4. So there are 2 ways we can write that, as we discussed before. We can write that equivalency. We can write it as 1 gram over 100,000 milligrams, or 1,000 milligrams over 1 gram. And the question you should be asking yourself, hopefully, is how do you choose to use 1 gram over 1,000 milligrams or 1,000 milligrams over 1 gram? And that is what we will discuss next. So you need to set up your conversion factors so that the final unit you want on top is on top of the last conversion factor. So if we scroll back up to the top, and let's remember, the final unit we're looking for is grams, and our conversion factor directly relates our starting unit, milligrams, with our final unit, grams. And so we want to pick the conversion factor where the last conversion factor, the last conversion factor we have has the unit we want in the end. And here we only have one conversion factor, and the unit we want in the end is grams. So we want to pick the conversion factor with grams in the numerator. And there it is. Alrighty. The next thing we need to do is we just need to solve. Finish setting up our problem and solve, showing how the units divide out. Now, if you are not familiar with fractions, remember in fractions you have the top line multiplied by the top line and the bottom line multiplied by the bottom line. Notice here that there's a multiplication symbol in between. And any units that are diagonal will cancel out. So we can just take that unit, bam, and slash right through it. Then when we complete the math, we're left with 4.5 grams over 1,000, and when we divide that out, we get 0.0045 grams. So that tells us that 4.5 milligrams is equivalent to 0.0045 grams. And we have some more example problems. Here's another example problem. Let's say we have 0.7 hectoliters. Now, I capitalize hecto so kids remember that deca is also capitalized, and for some reason it makes it easier. So we're going from hectoliters to liters. Not a conversion you will see very often. So step number 1, we have to figure out what we're starting with. We are starting with hectoliters. Step number 2, we have to figure out where we want to go, and hopefully you can see that that is liters. That's what we're looking for. Step number 3, we have to figure out the relationship, oh, come on computer, between hectoliters and liters. And if you're familiar with your metrics, you should hopefully know that there are 100 liters in 1 hectoliter, or 100 liters equals 1 hectoliter. That is the exact same thing. Not quite sure why it's there twice. Alrighty. Excuse the computer. So the next thing we need to do is figure out how to set up that as a ratio. So we can write it 100 liters over 1 hectoliter, or 1 hectoliter over 100 liters. And then we need to, in step 4, think about how we want to set that up. So the unit we're looking for in the end, liters, is on the top of the conversion factor. And if you look at these, hopefully you see that in this one, the liters is on top, so we want to choose the conversion factor on the left. Then the last thing we need to do is we just need to set up our problem, and we need to solve. And once again, I always think it's helpful to strike out those units. And when we do the math, we get 76 liters. Now, this can get trickier if instead of metrics, you are doing, let's say you're doing word problems. And we're going to skip through the second example problem. And we are going to look at non-metric problems. They work the exact same way, except for often they involve more steps. So we want to start by looking at how many seconds are in a year. And we are going to, of course, again use this happy 5-step method to solve dimensional analysis questions. So the first thing we have to think about is, what are we actually trying to figure out? we know that we're starting with 1 year, and we want to convert that into seconds. So the first thing we need to write down is what unit we're starting with. And in this case, we are starting with a year. And the next question we need to figure out is, what unit are we trying to get to? And we're trying to get to seconds. Then here's where we're going to get a bunch of conversion factors, because the next thing we need to do is think of all the conversion factors that relate years to seconds, that can get us from one to the next. Okay? There we have the top half of our conversion factors. And we look at that, we know that, hopefully you know that there are 365 days in a year, there are 24 hours in a day, there are 60 minutes in an hour, and 60 seconds in a minute. So I started out with one that had years, and I just worked my way down until I got one with seconds, because that's what we're trying to get to in the end. The next step we have to look at, if the computer will let me, is we have to look at how we're going to organize these to solve our problem. Once again, we want to do it so the unit we want in the end, second, is on the top of the last conversion factor. So what I usually do is I start by writing what I'm starting with, which is 1 year, and then I leave a bunch of empty space, and then at the end I put the last conversion factor I want. And if you remember, we want seconds. So the last conversion factor we want is 60 seconds per minute, because hopefully that is going to give us the unit on top that we want in the end. And I'm sorry, these are on split pages. So when I look at it and I just futz with my units until they all cancel out, this is what I get. Oops. I get 365 days in 1 year, and notice that the days in the first ratio cancels out with the days in the next. Then I need to get rid of my hours, and note that hours in the second conversion factor cancels out with the hours in the bottom of the third conversion factor. And then my minutes cancel out. And I'm left with seconds. So beautiful. And then the last thing I have to do is I just have to multiply all those out and solve. And that, when you do the math, that is what you end up with. And there it is in standard and scientific notation for you both. Hope this is helpful. If you have any questions, please come see me.